If you recall, a golden rectangle is defined to be a rectangle in which its length divided by its width yields the golden ratio. Given this rectangle, and if we assume it is a golden rectangle, then we should obtain the following. If we take the length of the figure and divide it by its width, as shown here, length over width, it should be equal in value to 1 plus the square root of 5 all over 2, or approximately equal to 1.618033989, continuing to infinity. I would like to next visit the topic of constructing a golden rectangle. As you recall from your geometry classes, and maybe even your 8th grade math classes, you spent some time doing constructions. The Greeks were famous for using constructions to prove mathematical facts. What I would like to do first is to go back and review with you some of these facts of constructions that will help us better understand what I'm going to do to construct a golden rectangle. First of all, you'll notice there is a dot or point in the middle of the screen. What I'm going to do using a smartboard is I'm going to take a compass, which is in the smartboard software, and place it right on top of that dot as best I can. Now, these compasses are a little different than what you're used to using, so bear with me as I try to show you what it is I hope to explain about the use of a compass. If I put the point of the compass exactly as best I can on that dot, okay, and I rotate the compass using that point, I have obviously drawn a circle. And as you recall from your geometry definitions, a circle is simply a set of points all equidistant from that single point called the center. Alright, now another thing you must understand about smartboards is if I want to draw a segment, which is a straight line segment, all I need to do is use the line drawing tool. And one thing neat about a line drawing tool is it does always give you a straight line. And notice if I want it to be perfectly horizontal, it snaps into position of what I call perfect horizontalness. It also allows me to draw a line segment, and I can snap it to perfect verticalness. And if I take these two segments and have them intersect each other, as you will see here, they should be what we call perpendicular to each other, right? Because this is perfectly vertical and this is perfectly horizontal. So that's something we're going to keep in mind, is that I can form right angles by drawing two segments using the smartboard. Another thing I would like to visit in relation to the circle, however, is this concept. If I draw a line segment from the center of the circle out to the edge, that, as you recall, is called a radius. And that radius is exactly the same as any radius I will draw in this circle. Okay? So these three radii, plural for radius, are exactly the same length. Now, keeping that in mind, also recall that this distance here, okay, along from here over to here, along the edge of the circle, right along there, is called an arc. And you notice that an arc is a piece of the edge of a circle, okay? And any line segment I draw from the center point of the circle out to that arc would have to be exactly the same length. So in other words, if I draw another arc here, another radius here, it is exactly the same as these other two. I noticed that on this particular circle, this radius right here, I did not draw very carefully, and it did not reach the edge of the circle, so its length would be a little different than these three. But had I drawn it correctly, it would have been just fine. So looking at this page, a couple other ideas come to mind. to review what we just looked at. Obviously up here is a circle, okay? Down here are two parallel lines which intersect this circle, all right? And you'll notice that this angle formed by these two radii intercept this particular arc. And notice these radii would be exactly the same length because they go to the same arc from the center of the circle. So we want to keep that in mind a little later when I do the construction of the golden rectangle. Now, looking to the right side of this page, you will notice there is a right triangle. And you're familiar, I'm sure, with the rule of Pythagoras from this course and from before. And you'll notice I'm missing the longest side up here, which I'm going to refer to as the side x. I need to find the length of x, but you'll notice this is kind of a special right triangle in that one side or one leg is 1 and the other is 2. In other words, the relationship between the two legs are such that one side is half the length of the other. We're going to come back and talk about that in a little while too. So let's quickly review the rule of Pythagoras here, and allow me to just slide this down a little bit. You will see here that I'm going to put the rule of Pythagoras down first. The rule of Pythagoras simply states that a squared plus b squared is equal to c squared. I've just written it backwards. Same thing. All right. I plug in the values of a and b, and I'm going to square them. They are 1 and 2. And squaring 1 and squaring 2, I get 1 plus 4, or the value of x squared is 5. But of course, what I'm looking for is the value of x, which of course, by finding the square root of each side of this equation, we find it is radical 5. So this particular side up here has a value, or the hypotenuse has a value of radical 5. We will come back and visit this concept in a little while as well. Now that we have taken the time to look at a few prerequisites to help us with geometric constructions, I'm going to attempt to construct a perfect golden rectangle. To do this, what I have to do is start out with a square. So what I'm going to do is I'm going to use the drawing tools of the Smart software, and I'm going to produce a square. So here is a particular square I want to work with. Okay, now what I'm going to do is I'm going to move this square up on the screen a little bit more. So I'm going to turn it on here so that I can move it, and I'm going to position it right about there. Okay, now it may be a tad too large, so I think what I'm going to do is shrink it just a little bit. That's a similar square to the one I had. Now you'll notice that this square is not of any particular size. Okay? Now, to do the construction, I need to bisect or cut in half the base of the figure. And may I just say this about the base of the figure? It's in a relationship of perfect horizontalness. In other words, this is parallel to the bottom of our screen. And what I want to do is cut it in half. Now, I don't know if you remember this, but in geometry, there is a construction which you can do to bisect any line segment. And it involves using the compass. So what I'm going to do is I'm going to turn the compass back on. Okay, bring it out here. And I'm going to stretch it out. Let me flip this to the other side first. Alright, I'm going to stretch it out like so, and I'm going to put the compass at one corner of the rectangle, or the square. Alright, and I'm going to strike an arc, okay, like so. Now, what I have to do to perform this construction is take my compass and go over here and do exactly the same thing. Okay, put it right on the point. I'm going to bring the compass up to this location here, and I'm going to strike an arc from the other corner like so. Now let me get the compass out of the way here so that you can see it. Now, with the compass out of the way, to finish off the perpendicular bisector of this segment, all I need to do is connect this line down through this point and this point down here. Now you'll notice that if I take this segment and I move it over, I can line it up perfectly where the arcs cross each other. Oh, let me try that again. Okay. Now you can see, probably by eye, that these two segments here are exactly the same length. So in other words, I have bisected this segment, or the base of the square, into two identical pieces. My perpendicular bisector is quite a bit too long for what I'm going to do in the future. So what I'm going to do, and I'm not cheating to do this, I'm going to turn on this segment, okay, and I'm going to shorten it. And you can see that as long as I keep it in perfect verticalness, okay, I can shorten this segment and it won't get in the way. There we go. All right, so this segment right here, okay, bisects the bottom of the square exactly in half. Now I want to get these arcs out of here so that they aren't in the way, so I'll delete those. Okay, so I'm getting rid of those. Alright, so now you can see I have a square, and the base of the square has been bisected exactly in half. Alright, now I need some extra working lines on this figure. So what I'm going to do is I'm going to put some more horizontal and vertical lines on here. So the first thing I'm going to do, as I talked about before, I'm going to snap a line segment to perfect horizontalness. I'm going to take it and I'm going to put it across the bottom of the figure. And I'm not quite there, so let me get that lined up just a little bit better. There, that looks pretty good. All right. And I'm going to do the same thing with the top. But before I do that and put in that working line, what I'm going to do is I'm going to take my compass over here to the bisection point of the base, put the point there, and what I'm going to do is stretch the compass so that it is exactly the length from that bisection point to the top corner of the square. Let's see how I'm doing up there. I'm pretty close. Let me see if I can get it just a little bit closer. Down just there. That's pretty close right there. All right. And now what I'm going to do is I'm going to strike an arc from that point all the way down to my working line. So here we go. Okay. Now, get my compass out of the way. Now, I'm also going to take from this bisection point, and I'm going to draw up to this point a perfectly straight line. Notice I don't have a straight edge to use to do that, but I can use the Smart Tools. All right. So I'm going to start here, and I'm going to draw a line segment up to there. Okay, now I don't think the bottom of this segment is quite right, so what I'm going to do is I'm going to highlight this segment and get this point right where she belongs. Okay, there we go. Now I believe that I'm finished with the compass, so what I'm going to do is make it disappear. Give me a second to do that. Okay, let's bring it down here. And we'll delete the compass because we will not need it again to finish this construction. All right, something I want you to notice. Notice the distance from here to here is a radius of the arc, just like the distance from here to here is a radius of the arc. So please keep that in mind as we continue and go on with this construction. All right, I need some more working lines. So what I'm going to do is turn some more of them on. I'm going to do another horizontal line up here. And what I'm going to do is I'm going to bring it into position so that it's perfectly parallel to the base and coincides with this top segment. I'm going to construct a vertical line. Okay, and I'm going to put that in position so that where the arc hits the base work line of the figure, like so. That looks pretty close right there. Now, what I want you to notice is this. I have not cheated in any way because this segment up here coincides with the segment which is the top of the square. It's in perfect horizontalness, just like the bottom is. This is in perfect verticalness. And I think you can see we have a rectangle here. Now, to help you see that more easily, what I'm going to do is I'm going to bring this down here. I'm going to bring this up here. Okay. I'm going to shorten this one. You notice they snap right back to perfect horizontalness, so you know I'm not messing up the figure at all. There we go. I contend that this is a golden rectangle. And let me show you why. To prove that this figure, the rectangle shown, is indeed a golden rectangle, here's what I'm going to do. Let's assume that the original square that I started with has dimensions of 2 units by 2 units. If that's the case, this is 2 units long. This is also 2 units long. This is 2 units long. And so is the bottom of the square, which of course now would be 1 and 1 because of the fact that I bisected it. Now wait a minute. Since this line segment here is in perfect verticalness, pardon my expression, the bottom of the rectangle is in perfect horizontalness, therefore these two are perpendicular to each other, which tells us that right here we have a right angle. Now if that's the case, and we do have a right angle, the 1 by 2-legged right triangle there is a right triangle, okay? Since it is a right triangle, we can find the length of its hypotenuse. But wait a minute. We did that recently. We did it over here. Let's go back and take a look. We did it right here. We took the rule of Pythagoras, although the triangle is oriented a little differently, we found that its hypotenuse was radical 5. So if we go back over here and look at this figure, this must be radical 5. But wait a minute. This segment from here to here, or the hypotenuse, is a radius of the arc that we drew in the figure. There is another radius shown on this figure, which has to be exactly the same length, and it goes from here over to here. So this must be radical 5. So the base of this particular rectangle must be radical 5 plus 1 more, or 1 plus radical 5. And so if I take the length of the figure and divide it by the width of the figure, which of course is 2, the distance from here to here, I get something that looks very familiar. And what is it? It's phi, the golden ratio. In other words, 1 plus the square root of 5 all over 2 is obviously exemplified in this particular figure. Therefore, I have successfully constructed a golden rectangle.